Well, welcome. What I'm going to try to do is I'm going to try to teach trig and everything you need to know how to do trig without your calculator in about hopefully 15 minutes. All right, here we go. First off, when you talk about trig, okay, what you need to know is that there are, okay, difference between degrees and radians, okay? Radians are another way of basically writing out and representing a angle. Okay, and so when you talk about angles, angles can go from, we know in basic geometry, angles go from 0 to 180 degrees. Okay, however, in trigonometry, we are going to go all the way around a circle, and we can do that several different times. So really, we can go from 0 to 360 degrees. All right, 360 degrees. And if you want to go more than that, you just keep on adding 360 degrees to it and go forwards or backwards, and you can have this. Okay, so if you go around the circle twice, we would have 2 times 360. All right, and that would give us a 720 degree angle. All right, that's 2 times around the circle. Now, you can also go backwards. If you go backwards, whoop, all right, going this way, all right, that is negative 360 degrees. That is a negative 360 degrees. And that's what we know from there. Okay, so we got 360 degrees and we have all that kind of cool stuff. And now the next thing is we need to understand, all right, what is a radian? Okay, now what is a radian? Well, a radian, okay, is a representation of a circle in what we call a unit circle. A unit circle. All right, and when we talk about a unit circle means we only have a radius of 1, okay? 1 unit, all right? 1 unit. So when we draw this horrible circle that I just did right here, we have these different intercepts we have right here. This is going to be 1, 0, and then we have another point up here, which is 0, 1, and then we have another point over here, which is, all right, negative 1, 0, and then we have another point if we put on a coordinate plane of 0, negative 1. Okay, and we have that. All right, now with a unit circle is actually in radians. Radians are actually the arc length of a unit circle. And so when we talk about radians, really what we're talking about is arc length. Now, if you're talking about arc length, well, a whole entire circle, okay, so if you think about this, 360 degrees is an entire circle around, and since we're talking about arc length of an entire circle, that's going to equal in radians, well, that is the circumference of the circle. And how do you find circumference? Well, that's 2 pi r. And since we have a unit circle with a radius of 1, all right, well, we would say, that's a radius. That's radius of 1. We know that we're going to have 2 times pi times 1. And therefore, we have 2 pi. So the first thing you have to remember is that 360 degrees equals 2 pi. That is what we know as a radian. So the arc length of an entire unit circle is 2 pi. Now, this is where it gets really lots of fun, is that from here, this is where a lot of students don't realize, is that we can find out any other angle by figuring out a ratio. So for example, if I want to figure out this one right here, okay, 180 degrees, well, 180 degrees is half of 360, so it's going to be half of 2 pi, which is going to equal pi. So yes, 180 degrees equals pi radians. There we go. So 180 equals pi. You have to remember that. 180 equals pi. And therefore, we can figure out a bunch of other ones. If I wanted to go 270 degrees, 270 degrees, all right, well, how do we go right here? Well, 270 degrees is what ratio of 2 pi or pi? Well, we can figure this out. Figuring out a ratio, well, 270 degrees is to 180 as to the radian we're trying to figure out, which is 2 pi. So a radian, if we multiply right here, is really going to be pi times 270 divided by 180, which we can reduce to 3 pi over 2. Bada bing, bada boom. That's how we got it. So this now brings us to another little formula we should know, is that if you're given a degree of an angle and you divide that by 180 degrees, okay, that ratio is equal to the radian of the angle divided by pi. All right, because 180 equals pi, and it's what we call a proportion. And so here is a little formula of the proportion of how you can figure out radians or degrees. Just fill them in and solve. Okay, cool, neat. All right, so going through here, you probably want to know all the basic radians that you want to know. Well, if we know that 180 degrees is equal to pi, and we know that 90 degrees, well, what's 90 degrees? Well, that's half of pi, so it'd be pi over 2. All right. If you want to know what 60 degrees is, well, 60 degrees is 1/3 of that, so that's going to be pi over 3, right? Because 60 in that's 1/3 of a pi. And then if we want to go in 45 degrees, well, how many is 45? Well, 45 going to 180, well, that's going to be pi over 4, right? Because it's 1/4 of 180. Okay, and if we want to go to 30 degrees is equal to, okay, well, we divide that, we have pi over 6. So it's 1/6 of 180, that equals 30, and so we have that right there. So once again, pi equals 180 degrees. All right, and this is in radians, and there we have it. Now, the cool thing is that all of these are multiples. So whenever you see pi over 2, if I want to have a multiple of that, that would be like, well, let's say 3 pi over 2, and we already solved that over here. Well, 3 pi over 2 is really 3 times, well, pi over 2, which is 90 degrees. All right, well, 3 times 90 degrees is equal to 270 degrees. Bada bing, bada boom. Look at that. What do you know? All right, so for example, if I had pi over 3 and any multiple pi over 3, so if say a 4 pi over 3, that's going to be, well, 4 pi over 3, well, it's 4 times 60, so 4 times 60 degrees, and that's going to equal 240 degrees right there. Okay, cool. And if I go over here, let's say I had 5 pi over 4, well, 5 pi over 4 is going to be, well, 5 times 45 degrees, all right, and that's going to equal 225 degrees, and so on and so forth. And we can do this. We can go, I don't know, 11 pi over 6. Well, that means we take 11 times 360, so it'd be 330 degrees, and we have all those other ones. And there you go. That's what you have it. And so really, by knowing these little formulas right here, all right, you can find out all the other types of angles just by using the multiple. So just multiplying. Okay. Well, that's pretty cool. Well, let's see how this all applies to everything that we want to do, because from here, we want to figure out how to find sine, cosine, and tan, because that's going to be the next thing, is how to use trig ratios for all these different angles, okay? How to use the trig ratios. Now, the trig ratios, as you should know, all right, I'm going to change this. I'm sorry about all this flipping back and forth right here, but I know it. All right, so, for example, you have to know the sine of an angle. You have to know the cosine of an angle, you have to know the tangent of an angle, and then you have to know the cosecant of an angle. All right, then the secant of an angle, and then the cotangent of an angle. All right, this is sine of an angle, this is cosine of an angle, and this is tangent of an angle. All right, so the thing is that most of the time what we use is, I use for the trig ratios what you learned in geometry. So what we know is this little phrase of so ga to SOHCAHTOA. All right, the sine of an angle, as we know, is always opposite over hypotenuse. All right, the cosine of an angle is adjacent over hypotenuse, and the tangent of an angle is the opposite over adjacent. And so when we talk about a triangle, all right, right here, here's the hypotenuse. We're talking about a right triangle. Here is the angle we're always going to be referring to. All right, here's the opposite, and here's our adjacent. Okay, so opposite of the angle, adjacent to the angle, and the angle is always going to come from the center or origin right there, and there's our hypotenuse. Okie dokie. Now, if you're wondering what is cosecant, well, cosecant is really equal to the reciprocal of sine, 1 over sine of the angle. And so what is that going to be? Well, it's the reciprocal of the sine ratio, which is, instead of being O, it's going to be ho, ho, ho. For secant, secant is 1 over cosine of an angle, which instead of being, all right, ka, it's going to be ha. All right, it's the reciprocal of that. And for cotangent, cotangent is the reciprocal of tangent of the angle, and therefore instead of being ao, all right, or oa, it's going to be a All right, and that's what we have right there. So cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Okay, so now that we know over trig ratios, the next thing we have to do is figure out how can we solve these various trig ratios. Well, to figure out how we can solve these various trig ratios, let's just try to figure these out. Well, we talk about this unit circle thing, and the unit circle, which is pretty awesome, and I know a lot of math teachers go through and talk about this unit circle, and we have to put them, and we have these points right here. But the key thing you have to remember, okay, is yes, the trig ratios, but also sine is y, all right? Because when we talk about our unit circle, all right, our unit circle, remember that this has a radius of 1. This has a radius of 1. And so when we talk about a radius of 1, that's our hypotenuse. We have our opposite side, which we have our point, is going to be x and y right here. So if I have a point on this unit circle, xy, all right, we have our hypotenuse, which is 1, and our x is our horizontal, and our y is our opposite. Okay, this is our adjacent, and this is our vertical axis, which is going to be y. Well, if I take this, and this is our little angle right there, sorry this is so small, but if I take this angle of sine, and I took it on the unit circle, we realize that sine actually equals y opposite over hypotenuse, which is 1, which means that sine of an angle is y. So I always remember this, sine y. They rhyme, sine y, sine y, sine y. So sine of an angle equals y in the unit circle. Cosine of the angle, cosine is going to be adjacent, which is x, over a hypotenuse, which is 1. So we have cosine, which is going to be cosine of the angle equals x in a unit circle. So in a unit circle, we have cosine x, cosine x. This is for when we talk about a unit circle, which is most of them that we're going to be referring to. So all of these ones, we can come from our unit circle, all right, our unit circle. Or what you may recall is that we can also use, all right, some other basics, because all triangles, all right, if they have the same angles, all right, so the key ones that we have to know how to use, all right, are the 30, 60, 90, and the 45, 45, 90. So the ratio of a 45, 45 and a 30, 60, 90 is 1 to the 1 to the radical 2 for a 45, 45, 90 degree right isosceles. All right, because these sides are equal. So 1 to the 1 radical 2. And the 30, 60, 90 triangle is 1 radical 3 and 2. All right. So these are the basic triangles. Now, why am I using this? Because 45, 45, these are all the basic ones that we know from our radians and that we began to do this. And all multiple of those are going to be also a part of our basically traditional, all right, basic ratios. Okay. So here are our trig ratios. Here are our basic ratios of some common ones: 45, 45, 9 degree right isosceles, 1 to the radical 2. Come on now. And then the 30, 69 mimal, which is 1 radical 3 and 2, 1 radical 3 and 2, 1 radical 3 and 2. So knowing that sine is y, cosine x, we can now go through and identify how to solve each one of these in the unit circle. So what I do is a triangle method is I go from here. So I say if I want to find out what sine of let's say pi over 6 is. Pi over 6, I always convert this into degrees. So I'm actually thinking about sine of 30 degrees. Well, sine of 30 degrees, if we go over here, 30 degrees, if we talk about on our coordinate plane, is going to be in this quadrant, the first quadrant, because this is 30 degrees. Well, if I take 30 degrees right here, I'm going to bring this down, okay? And what we have next is now I have this right triangle. I'm going to create a right triangle, okay? Now this could be a unit circle, it could not, it doesn't really matter. Well, right here we have 1 radical 3 and 2, 1 radical 3 and 2. Well, if I want to go over here and want to figure out this out, I can go sine of 30 degrees. Well, sine of 30 degrees is what ratio? Opposite over hypotenuse can be 1/2. Or if you want to create this into a unit circle, we need to make this a 1, so the hypotenuse has to equal 1. Well, how do I do that? I have to divide everything by 2. Divide this by 2, divide this by 2, divide this by 2, and then we can use our unit circle phrase of sine y cosine x. Well, right here, this is always our y, this is always our x, and so when we have our unit circle, we know that the sine of 30 degrees is going to be 1/2. Oh, what do you know? It's the same thing. And we know also we could find out what the cosine of 30 degrees is. Cosine of 30 degrees is going to be adjacent. All right, radical 3 over 2u. Or if we had and create a unit circle, we can see it's going to be square root of 3 over 2. Cool. Awesome. So we can do this for pretty much everything. Everything. And when we look for this for everything, and so what we're going to do is going to find, all right, whatever other types of triangles or angles that we want to do. So if we want to take the sine of, I don't know, 5 pi over 3, 5 pi over 3. So 5 pi over 3, what does this tell us? Well, this tells us right here, 5 pi over 3. Well, I am talking about pi over 3, which is going to be a 60-degree angle. 60 times 5 is, all right, well, 300 degrees. So we have over here, it's going to be in the fourth quadrant. Okay, so you know the quadrant 1, 2, and 3. All right, and that's the fourth quadrant. This is what we refer to as a reference angle. This angle is always going to be known as our reference angle. So that angle right there is going to be, all right, we call that a real reference angle, and that's going to be pi over 3. It's always going to be whatever this value is. So if you get rid of everything, all right, all the coefficient, we just take pi over 3, it's going to be that. So pi over 3, once we know, is also going to equal 60 degrees. It's not 60 degrees, I'm sorry. It equals 30 degrees. 30 degrees. No, sorry, it is 60 degrees. 60 degrees. Okay. Now, from 60 degrees, we know that opposite 60 is square root of 3. This is going to be a 1, and this is a 2u because we know this is 30 degrees, and this is 90 degrees. All right, cool. So if I want to find sine of 5 pi over 3, sine is opposite over hypotenuse, so it's going to be equal to square root of 3 over 2u. Square root of 3 over 2u. And that's how we go. Okay, if you want to make this into a unit circle, once again, divide this by 2, divide this by 2, divide this by 2. Sine is opposite, sine is y. Here's my y value going up and down, so square root of 3 over 2. What do you know? Cosine of 5 pi over 3 is going to equal, all right, 1/2, and so on and so forth. Cool, huh? Pretty easy. And we can do that for any type of ratio, any type of triangle, whatever angle you want to know how to do. Just use triangles, put it in the correct quadrant. So find the triangle. So here's the little steps. Find the angle. All right. Second step, draw and correct quad. Third step, create triangle. With ratios. And then the last step is solve. Boom. All right, so you pretty much can do this for anything, and if you don't use your calculator, I'll just tell you they're either going to be a 45, 45, 90, or 30, 60, 90. And so knowing the ratio of 1 to the 1 to the radical 2 for a 45, 45, 90 degree, or 30, 60, 90 triangle, which is opposite 30, is always going to be, all right, 1, radical 3 is always up to the 60, and 2 is always the hypotenuse. That's what you have to do for every single one. And so if you want to find tangent, all right, tangent of 90 degrees, or if you want to find tangent of pi over 2, all right, well, once again, using the unit circle, where is tangent of 90? Tangent of 90 is up here. Oh, 90 degrees. Whoop. It's not a triangle, but we know this ratio is 0 and 1. Okay, tangent is, well, if you also know, one of the ratios of tangent is sine, all right, over cosine, which we know is y, sine y, over x. Sine y, cosine x. And so, for the tangent of 90 degrees, tangent of 90 degrees is going to equal y, 1 over 0. 1 over 0, which we know is undefined. And that can help us with so many much more, all right, with the graphs and so on and so forth. But the key thing that you have to know how to do is you have to know how all the radians. Okay, understand a radian, all right, is an arc length of a unit circle. A unit circle has a radius of 1. The radians come from an arc length of when 360 equals 2 pi. Pi actually equals 180 degrees. All right, pi radians equals 180 degrees. And when we go from here, we can figure out any other degree of radian by using a little ratio or proportion. Degrees over 180 degrees equals radian over pi, and then solve. Just place and submit. And then from here, we also know that once we have this little ratio, we know that we can find all the basic radians by just using little proportions or ratios of knowing that 90 is half of 180, so it's going to be half of pi. All right, 60 is 1/3 of 180, which is going to be 1/3 of pi, and so on and so forth. We then go to the trig ratios, SOHCAHTOA. All right, opposite of hypotenuse, cosine is adjacent over hypotenuse. There, cosecant is 1 over sine. Secant is 1 over cosine. Tangent is 1 over or cotangent is 1 over tangent. All right, know that tangent, I guess over here, tangent actually equals sine over cosine. All right, and from here, we can know that using the unit circle, sine y, cosine x, and using our trig identities, all right, and using this little formula, we can draw out the triangle, all right, find the angle, draw it in the correct quadrant, create a little triangle, and then just solve whatever we want to do with the ratio. All right, well, I hope this helps you. It was more than 15 minutes, about 20, and, well, good luck and God bless in the rest of your trig.